नाउ वेलकम टू फिजिक्स मेड इजी चैनल। और इसमें आज का जो हमारा टॉपिक है वो पोलराइजेशन ऑफ लाइट है। और ये टॉपिक हमें पोलराइजेशन ऑफ लाइट एक पर्टिकुलर फिनोमेना है। ये दो चीजें बड़ा क्लियरली एस्टेब्लिश करता है। वन, जो हम वेव ऑप्टिक्स पढ़ रहे हैं तो इसमें वी नो इट वेरी क्लियरली को कि जो हमारी वेव है, जो लाइट है, इसकी फर्स्ट लाइट हैज वेव नेचर। एक तो ये वेव नेचर इससे एस्टैब्लिश होती है, और उसके बाद जो दूसरी चीज इससे अच्छी तरह से एस्टैब्लिश होती है वो वेव नेचर के साथ साथ इसकी ट्रांसवर्स नेचर। क्योंकि वेव हमारे पास लॉन्गिट्यूडिनल भी होती है और ट्रांसवर्स भी होती है। साउंड वेव्स कभी भी पोलराइज नहीं होती। उसका रीजन क्या है? बिकॉज साउंड वेव्स आर लॉन्गिट्यूडिनल इन नेचर। लाइट वेव्स हमारी जो हैं ये पोलराइज होती हैं। ये क्यों पोलराइज होती हैं? उसका सबसे बड़ा रीजन ये है बिकॉज दे आर ट्रांसवर्स। तो पोलराइजेशन ऑफ लाइट proves the transverse nature of light। तो अब पोलराइजेशन को अच्छी तरह से अंडरस्टैंड करने के लिए जो मुझे मालूम होना चाहिए वो सबसे इंपॉर्टेंट पार्ट ये है इलेक्ट्रिक वेक्टर। इलेक्ट्रिक वेक्टर के बारे में मुझे मालूम होना चाहिए इफ वी आर स्टडिंग पोलराइजेशन। तो अब इसमें हमारे पास एक इलेक्ट्रोमैग्नेटिक थ्योरी ऑफ लाइट है। वो ये बोलती है कि लाइट इज मेड अप ऑफ टाइम वेरिंग इलेक्ट्रिक एंड मैग्नेटिक वेक्टर्स। और उसी थ्योरी में हम ये बात भी जानते हैं दैट C is equal to E divided by B। तो इससे E is C times B। तो what this means? This means that electric vector is much more stronger than magnetic vectors। And here we have got a system of three perpendicular vector. Let me call it as x-axis, this as y-axis, and this as z-axis. Now this electric field is along y-axis, and magnetic field, which is blue colored, this is along z-axis. Now electric and magnetic fields, they are perpendicular to the direction of propagation। तो एक ये फॉर्मूला हमारे पास है S इज इक्वल टू E क्रॉस B। S इज पावर और पॉइंटिंग वेक्टर। इट इज द एनर्जी रेडिएटेड पर यूनिट एरिया पर यूनिट सेकेंड। तो X की डायरेक्शन में जितनी एनर्जी जाती है दैट इज डिपिक्टेड बाय S। S shows us the energy that travels in the direction of X, and E is the electric field vector in the direction of positive Y and negative Y axis। So it is the direction of vibration of electric vector, and Z axis, this is the direction of vibration of magnetic vector। Now we will take electric vector into consideration। Why? Because electric vector is very much powerful in comparison to magnetic vector, and our eyes are more sensitive to electric vector than to magnetic vector। So these two logics inspire us to use electric vector to represent light, and we shall be assuming electromagnetic nature of light। Now what is unpolarized light? Before we understand polarized light, it's important to understand unpolarized light। Unpolarized light now we have just learned that light has transverse nature. So light vibrates electric vector. Light means electric vector. Electric vector vibrates in all possible directions perpendicular to this plane. Now, in the plane of this board, direction of propagation is perpendicular to the plane. And now electric vector can vibrate in any direction in this plane. It means electric vector is having millions of direction and it keeps on changing its direction. Only one condition is to be satisfied, that electric vector and magnetic vector, they should be perpendicular to each other, they should be in phase, and they should also be perpendicular to the direction of propagation of light. So this is the nature of unpolarized light. In unpolarized light, the direction of vibration of electric vector can be any, and it changes million times per second. Now in polarized light, now we shall be seeing polarized light. In polarized light, this is unpolarized light. In this plane, this red vectors, they have got many directions, so this is unpolarized light. And now here we have got electric vectors like this. So electric vectors in unpolarized light, they have got many directions perpendicular to the direction of propagation. And here we are having a polarizer. Now this polarizes the light, and after polarization, electric vectors only in one direction, they will be available here. Other electric vectors which were in for example this direction or in this direction, all these electric vectors, they will be blocked. Only one electric vector that will pass through the polarizer like this. So the vibrations will be restricted to this y-axis. If I assume this to be x-axis, this is x-axis, this is x-axis, and this is y-axis. Now vibrations are restricted to y-axis. In this case, if this is x-axis and this is y-axis, this is x dash and this is y dash. So in this plane, electric vector was vibrating in all possible directions, infinite number of directions. And once it passes through this polarizer, electric vector vibrating in one direction is only allowed to pass. Others are blocked by this polarizer. So this is unpolarized light. Light before polarizer is unpolarized. Light coming out of the polarizer is polarized. Now, it is a light wave in which vibrations of a wave are present in just one direction, in the plane perpendicular to the direction of propagation. The wave is said to be linearly polarized or plane polarized. The phenomena of restriction of vibration of electric vectors of light in one particular direction of vibration is called polarization. So this is the formal definition. And how do we represent them? Vibrations in the plane of paper, they are represented by arrows. जो इस plane of paper में vibration है, they are represented by these arrows. So these are bidirectional arrows indicating that vibrations are taking place like this. So this line represents the main position. Now vibrations perpendicular to the plane of the paper, they are represented by dots. Dots means the electric vector is moving perpendicular to the plane of this board towards me and away from me, or towards you or away from you. So till now we have covered unpolarized nature of light, infinite number of direction of vibrations in unpolarized light. There are infinite number of directions of vibration of electric vector. In polarized light, the direction of vibration is restricted to 1, and this light is known as polarized light. Now, for depicting polarized light and unpolarized light, we make use of these bidirectional arrows. Bidirectional arrows represents vibration of the electric vector taking place in the plane, and the vibration perpendicular to the plane, they are represented by dots. Now the next is vibrations perpendicular to the plane. Vibrations perpendicular to the plane of the paper are represented by dots. Vibrations in the electric vector is called plane of vibration. Now there are two important points. The plane in which vibrations are taking place, that is known as plane of vibration, and the plane perpendicular to the plane of vibration is known as plane of polarization. For example, if vibrations are taking place, now here we have got an example. In this case, vibration perpendicular to the plane of the paper are represented by dots. Vibration, the plane in which vibrations are taking place is known as plane of vibration. The plane perpendicular to the plane of vibration is known as plane of polarization. And now, we have one more important point here. This is unpolarized light. This is unpolarized light, and we have divided electric vector in along two directions. One is in the plane, other dots perpendicular to the plane of the paper. Now once unpolarized light passes through this crystal, then it becomes plane polarized. Now vibrations are taking place in the plane of your board, and plane of polarization is perpendicular to the plane of the board, shown by this broken line. The plane of vibrations is shown by A, B, C, D. Plane of vibration is A, B, C, D, and the plane of polarization is a plane perpendicular to plane of vibration K, L, M, and N. And now another important point. The phenomena of interference and diffraction, important point. Phenomena of interference and diffraction establishes wave nature of light, but they are silent whether the light wave is longitudinal or transverse. But longitudinal waves, we know that they cannot be polarized. So the phenomena of polarization proves us transverse nature of light. Transverse nature of light. Now here we have got experimental demonstration. So this is polarizer and analyzer. They can be two calcite crystals, polarizer and analyzer. Here we have got unpolarized light divided in two electric vectors in the plane of the paper and perpendicular to the plane of the paper, like this. And here we have got polarizer. Now the direction of this electric vector is in the direction of this axis. So perpendicular vector will be cancelled out, and there will be only vibration will be restricted to one direction, and we call this as polarized light. This is unpolarized light. Now polarized light is passed through the analyzer, and if the axis of the analyzer is parallel to the direction of vibration, then polarized light passes through it. Now what is important is we will rotate analyzer. Now when the angle between direction of vibration and this broken line axis is 0, then we say that then there is maximum intensity. As we will rotate this analyzer T2 along this line, along the direction of propagation, then the light intensity will vary. Here, in this position, the light intensity was maximum. Here, it was maximum. As we will rotate it, so it will start decreasing. When this angle will be 90 degree, when the angle between the polarizer and analyzer will be 90 degree, that there will be no light, and here we shall be having minima. Minima the matlab complete darkness. Darkness. So now if we rotate further, now the angle will, in the first segment up to this point, here the angle between the analyzer and polarizer is 0 degree. And intensity of light behind the analyzer is maximum. Now as we are rotating T2, angle between analyzer and polarizer is changing from 0 up to 90 degree. If we go from 0 to 90 degree, if we go from 0 to 90 degree, so intensity will vary from maximum to minimum. In linearly polarized light, here intensity will be 0. Now as we are further rotating the analyzer between angle 0 to 90 degree to 180 degree, it will vary from minimum to maximum. It will start increasing and maxima will be achieved at 180 degree. And now from 180 degree to 270 degree, it will be again from maximum to minimum. And from 270 degree to 360 degree, it will again be from minimum to maximum. So there will be two minimas and two maximas. If we rotate it through 360 degree, there will be two minimas and two maximas. Now, two very important basic concepts. Polarizer. What is polarizer? Polarizer is that produces plane polarized light. For example, tourmaline crystal, Nicol prism, Polaroid, etc. Analyzer is same as polarizer, but what is important is analyzer is used as the purpose of analysis, for the purpose of analysis, and polarizer is used for the purpose of polarizing the light. Now, another important process, we know that light obeys Snell's law. Light obeys Snell's law. But this is not always true. Birefringence. Birefringence is a particular phenomena in which when ordinary unpolarized light is made to pass through calcite or quartz. These are the two crystals, particular crystals. One is calcite and other is quartz. When light is made to pass through them, this is calcite crystal or quartz crystal. When light is made to pass through calcite or quartz, two refracted rays are produced. One is called E ray, other is called O ray. Now listen again. Once unpolarized light is passed through calcite or quartz crystal, then two rays comes out. One is called E ray, other is called O ray. Crystal which possess this property is called birefringent crystals. These are called birefringent crystals. E ray is extraordinary ray. It does not obey Snell's law. Note this line. And O ray, it obeys Snell's law. It obeys Snell's law and it is plane polarized. This is unpolarized light. It passes through calcite crystal. Now unpolarized light has been shown by two vibrations. One vibration taking in the plane of the paper, other perpendicular to the plane of the paper, or you can say we have divided light in all directions into two perpendicular components. One is in the plane of the paper, other perpendicular to the plane of the paper, and when it enters the crystal, we have got two direction of vibration, one in the plane of the paper, other perpendicular to the plane of the paper. One is E ray, other is called O ray. E ray is the ray which does not obey Snell's law. E ray is the ray which does not obey Snell's law. This does not obey Snell's law. And this is the ray which obeys Snell's law. This is the ray which obeys Snell's law. What is Snell's law? Snell's law is mu is equal to sine I divided by sine R. And if we can also have a diagram of this process. तो इसको हम ऐसे शो कर सकते हैं, ये मेरे पास एक I is angle of incidence and R is angle of refraction. ये मीडियम 1 है, ये मीडियम 2 है, और इसका जो रिफ्रैक्टिव इंडेक्स है म्यू रिफ्रैक्टिव इंडेक्स ऑफ सेकंड विद रिस्पेक्ट टू 1 इज इक्वल टू म्यू इज इक्वल टू साइन आई, मैं यहां से पे द्वारा लिखता हूं म्यू इज इक्वल टू साइन I divided by sine R. So this is the Snell's law. E ray does not obey this law and O ray obeys this law. And now we shall be moving to the next topic, which is Nicol prism. This is a very important article, Nicol prism, and we will do it in the next lecture. Thank you very much for listening this lecture, and one important request to all of you, kindly view these lectures, and if you like it, share it. If you don't like it, then kindly comment on it so that we can improve and serve you in a better possible manner. Thank you very much.